Hey everybody, this is math for Tuesday, 28th of April, and we, for Math 65, are talking about calculating areas of rectangles, which are different than what we did yesterday when we estimated for Math 76. This is actually calculating. So I want you to look here. We see that we have squares with the sides. This one, because a square has all sides equal, 1 centimeter, meaning all the measurements of that is 1 centimeter. And we would read this as 1 square centimeter. This one I've labeled inches because it's a square. This would be labeled 1 square inch. And if you had a foot measured, it'd be 1 square foot, a meter, 1 square meter. Okay? And you can either write square by saying square or squared. Okay, so it can either be centimeters squared, centimeters squared or squared centimeters. So let's try to figure out how we find the area. If you have a shape that is not a square, more of a rectangle, we have the length as 3 centimeters and we have the width as 2 centimeters. What this is actually saying is that I'm going to take and split this into 2. That's how many I have. So horizontally, I have 2. And then the 3 tells me that vertically, I separate it into 3. Now you can see how many squares would be needed to cover this rectangle. Well, 1, 2, 3, 4, 5, 6. So 6 square centimeters are needed to cover this shape. Now, a really simple, quicker way to do this is to just multiply 3 times 2. 3 times 2 is 6. And then you have centimeters squared, or you can write it 6 square centimeters. Both of those mean the same thing. Okay, and remember in area, your full label is always going to have the square. So let's try one more together. And I'm going to take this off of your practice problem. So I'm going to do A, and it has a picture here. It says my length is 4 centimeters, and my width is 3 centimeters. So my width tells me I'm separating this into 3. My length tells me I'm separating this into 4. Okay, but I also know that I can multiply 4 times 3 is 12 centimeters squared. And it's like square because it has centimeter and centimeters. So let's double check our work. 1, 2, 3, 4. 1, 2, 3, 4 times 3, right? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I just want you guys to do B, C, and D for your practice problems. And then the set includes everything. So for the one person who's on a half sets, you just have to do, let's see, it's sets 125, so it's odd. Okay, Math 76. Today's lesson is a little bit tricky because we're not in the classroom and I don't have a way to show you a protractor. If you have one at home, you can familiarize yourself with it, but luckily the lessons will have one drawn in. So we're just going to talk today on how to use a protractor and why we use a protractor. So a protractor is used to measure angles. It is shaped like a half circle. Excuse me. And there are 2 measurements, 2 lines of measurements. And let me help you understand what I mean by that. Okay, so this one starts with 0 and it goes to 180. And we know that 180 degrees, straight line is 180 degrees, okay? Which means that halfway through is 90 degrees. So protractors measure angles. So 0 to 90, 90 to 180. So we have 8, 7, 6, 5, 4, 3, 2, 1. That wasn't super even. Okay, and then 90, 100, 110, 120, 30, 40, 50, 60, 70, 180. These are all the measurements. Now, the bottom line starts with 0 on the other side. And we count this way from 0 to 90. So 0, 10, 20, 30, 40, 50, 60, 70, 80, 90 to 180. So you will see both of these measurements on here. So then 90, 100, 110, 120, 130, 140, 150, 160, 170. And these actually do line up. And here's why we have them in both directions. So if we have an angle that is measured, let me see what the measurement in the book is. Oh my goodness. So we have O, we have P, and A. And then we have a line, or angles, we're gonna draw here. Okay, and we're gonna label this B. Now, as you can see, this forms two different angles, right? So we have the angle, I'm gonna draw a little bit underneath it so you can see it. We have BOA, an angle facing that way. Okay, and then we have another angle, which is BOP. You could also say POB or AOB, that's fine. Now, whichever way my angle is facing, that is what line I use. So you always start at 0. So this angle, let's start with a smaller angle. It is facing this direction, right? So we have our point here and then it reaches out that direction. So we're gonna start at the 0 here. And from 0, we're gonna count. So 0 on this one is on the inside. And it hasn't hit 90 yet. And then you will notice in between each are 10 marks. So this one goes between, so this is 90, 80, 70, 60. So this is between 70 and 60 on the 5 mark. So this is a 65-degree angle, which means it's acute, right? It's less than 90 degree, so it's acute. Now for this way, because the angle is facing this way, we start at the 0, which on this one is the outside. So we go from the bottom line, we count from 0, and this passes 90, so it's bigger than 90, so we know it's going to be obtuse. Because we know that anything greater than 90 is obtuse, and a 90-degree angle is a right angle. Anything less is acute. So this one passes 90, 100, 110, 20, okay? And we're between 120 and 130, so we're 125 degrees. And so you would write this angle, so this first one, we are gonna name it AOB, and it's angle AOB, and this one is going to be angle, let's do POB, and then you write how many degrees. And for your practice problems today, I actually just want you to do the first ones where the protractor is actually given to you. Otherwise, you would need your own protractor. So just A through F is all that I'm going to require you guys to do today. You don't need to do the rest of them, even if you have your own protractor, because they will be writing the protractor in the lesson. When you guys have 125 odd. Okay, let me know if you guys have any questions. Thank you.